Have you ever seen a basketball arc through the air, or a bridge shaped like an arch? Believe it or not, both are connected to something we study in math. That is, quadratic equations. They can be used to describe how objects travel in curved paths and how structures remain stable. Today, we're going to explore quadratic equations, what they are, how they look, and how we can solve them. Let's start with the equation y equal to x squared. Here, the value of a, or the coefficient of x squared, is 1, a positive number. That means that the parabola opens upwards, forming a smile-like shape. Now, if we change the equation to y equal to negative x squared, the value of a becomes negative 1, which is a negative number. This makes the parabola open downwards, forming a frown-like shape. When you graph a quadratic equation, you get a curve called a parabola. If a is more than 0, then the parabola opens upwards like a smile. However, if a is less than 0, then it opens downwards like a frown. But why does this happen? It all comes down to a, the coefficient of x. If a is positive, then x squared is always a positive too. So the parabola keeps going upwards on both sides, which creates the smile shape. If a is negative, multiplying by a negative flips everything, so the parabola keeps going downwards on both sides, which creates the frown shape. The parabola is the reason why we see quadratic equations in real life, like the root of a ball or designs of a bridge. So it goes up, peaks, then falls down. First, let's define it. A quadratic equation is an equation where the variable is squared, and it usually looks something like this. A and B are parameters, while C is a constant. Now, an important detail to remember is that in a quadratic equation, A cannot be 0. Why? Because if A is equal to 0, then we won't have a square term anymore, meaning that the equation will be bx plus c equal to 0, which is a linear equation. Quadratic equations are interesting because they can have two solutions, one solution, or even no solutions at all, depending on their shape and discriminant, but we'll get into that later. An example of a quadratic equation would look something like this. We can see here in this equation that the value of a is 1, the value of b is minus 5, and the value of c, the constant, is 6. Another example would be, we can see here that the value of a is 2, the value of b is 3, and the value of c, the constant, is minus 4. Let's try solving x squared minus 5x plus 6 equal to 0. How do we do this? First, notice that the value of a is 1, since x squared doesn't have a coefficient. That means we can write x on both sides, because x times x is equal to x squared. Now, we're looking for two numbers that multiply to give the value of c, which is 6, and add up to give the value of b, which is negative 5. So what numbers multiply to 6 and add up to negative 5? They're negative 2 and negative 3. We know this because factors of 6 are 1 and 6, 2 and 3, negative 1 and negative 6, and also negative 2 and negative 3. And out of these, negative 2 and negative 3 give us the sum of negative 5. Now, this is what the equation would look like. To find the value of x, we take what's inside each bracket and make it equal to 0. That means x minus 2 is equal to 0 and x minus 3 equal to 0. So when we solve for x, we get x is equal to 2 or x is equal to 3. You might think, oh, factoring is quick and easy, but it only works if the quadratic splits neatly into factors. Let's say if the equation was x squared plus 3x equal to 0. You might be wondering, oh, but there isn't a value for c, the constant. The solution must be undefined, right? Well, that's not the answer, as you can find the solution by factoring x out first. So we take out x from both x squared and 3x. After you do that, it might look something like this. This works as if you were to multiply the values inside the bracket by x, then it would revert back to the original form. Now, since we know that a quadratic equation usually gives two possible values of x, using the method we used previously, we can find that x plus 3 equal to 0, meaning x is equal to negative 3. What about the other value of x? Well, that would just be equal to 0. So the answer would be x is equal to negative 3 or 0. Let's say, what if you have a number that's not so pretty and you can't factorize x out either? The solution would be to use the quadratic formula, which may look something like this. Since we're given the values of a, b, and c, we can use the quadratic formula. So if we were given an equation 2x squared plus 3x minus 7 is equal to 0, we can insert the values of a, b, and c into the formula. After inserting the values of a, b, and c into the formula, we can then find the discriminant, which is the value inside the square root. We can then solve for x. So the answer would be x is equal to 1.27 or x is equal to negative 2.77. It would be really hard to find the answer using factorization since the answer is in a fraction. That's why we use the formula instead. But using the quadratic formula takes up lots of time since you have to do all the calculations. So if you think you can do it by factorizing, then go ahead and do whatever that suits you best. Quadratics is a very useful tool that can be used in a variety of ways. It's found almost everywhere. It can be used to find the trajectory of a ball, the design of arches in architecture. In economics, quadratic equations are used to find the maximum profit, and even in physics where they describe acceleration and motion. And that's it for today. I hope you learned something new, and thanks for watching.